Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design using MATLAB Simulink. Today is day 23. We are going to discuss about a complete EV simulation with MATLAB Simulink. So I welcome you everyone here. I welcome all the participants. So can you able to hear me? Can you able to hear me? Am I audible? Can you please comment? Very good evening everyone here. I welcome yes Lokesh, Busha Vasant, Rajesh, Satish, Guru Bani, Avin, Mageshwari, welcome Sai Sudhakar, welcome Rama Devi, very good evening. Yes, Begum, very good evening. Karthik, Divya, very good evening. Chetan, Begum, Gautam, thank you participants. Thanks for your valuable comment. About the Pantech is a educational equipments manufacturing company. From Pantech, you can get lab equipments for EEE, ECE, computer science, IT, AI, robotic related products. You can get it from the Pantech. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 1.5 lakh students. Yes. Yeah, someone is commenting video Nahi Ahara. Okay. Yes. So you are comfortable with my audio and then video, right? Are you comfortable with my audio and video? Someone is commenting video is not playing. Attendance is not possible to check right now. So, let us start the class. So already 7 minutes we delayed. So are you ready to learn the concepts? So are you ready to learn the concepts? So please comment in the comment box. Super. Thanks, Gautam. Yeah. Yes. So are you ready to learn the concepts like how to integrate all these things? So because today I have about 4 demonstrations. So I will explain you one by one so that you can get more idea about it. Yes. Thank you, Hariharan. Thank you, Arivalagan. Thank you, Tamari Chelvan. Yes, right. See, actually, in the about the EV, so what are all the main components? So what are all the major parts if you take about EV systems? So can you please comment what are all the major components or major parts? So what are all the major parts of EV system? So can you please comment? What are all the major parts? Yes. So I am waiting for your comment. Battery, motor, body, and one more model BMS. Yes, correct. Motor control, motor, battery, controller. Yes, motor, controlling system. So please comment in a single line so that I can read. Yeah, Arivalagan, battery, PDU, traction motor, BMS, and then BCS. Yes, nearby battery, drive, gears, and then motors and vehicle systems. Great. Power electronics also not owned. Power electronics also one of the component. Alternator. Oh no. DC to DC converter. Yes, vehicle dynamics modeling, BMS. Okay, right. So let's move. Thanks for your comment. See, actually, for the EV system, first one is that electric vehicle body. Second one is the motor and inverter module and the battery model. So these four are the major parts of the EV system. So if you have a comfortable knowledge with these four things, then you can develop your own vehicle in the MATLAB Simulink. Right? Is it clear? Yes. So first one is vehicle body, motor or traction motor or E motor, anything you can say, you can call it, and inverter or I mean drive for the motor, and then battery model. So battery charging unit comes apart from that one. That is the secondary part of the EV systems. All right. So now, if you take a detailed components, actually in the vehicle structure, so there will be a wheel, vehicle body, and then gear systems, right? And in the electrical part, motor, battery, power control unit, and then onboard charger. And third model is that other assembly, other essential components. So like infotainment and then enclosures, airbag, safety systems, other things. So in this four mod, if you know the detailed idea about this four mod, then you can develop your own systems. And actually, if you take a research on the EV systems, so here everything is going to be like a performance evolution or performance improvement and then reliability improvement on any of one of this one. Like let us take BMS of performance evolution of the BMS for particular battery, and then performance efficiency improvement for the particular motor, then torque improvement for the particular motor, or direct torque control for the particular motor and EV applications. So like that you can kickstart your research. Right, and see other part. So this is the power flow. So from the onboard charger, the battery bank will receive a power. So once if the battery bank receive the power, then the battery bank will supply a power, is a enough power to the inverter. So this inverter will generate a control signal to the motor. So once if the control signal received the motor, then the motor will try to drive the vehicle body. So now your vehicle will get moved from the standstill position. So this is the actual power flow diagram. And now if you take a block diagram of this EV systems, see here as we know, the vehicle body is the final unit which is going to move from its standstill position, and then motor. Right. So what are the types of motor? Can you please comment? What are the types of motors is used in the electric vehicle systems? What are the motors are used in the electric vehicle systems? So can you please comment? So what all the motors are used in the EV systems for electric vehicle applications? Can you please comment? AC, DC, SRM. So please comment in the single line so that I can answer I can identify your answers. Aditya, we will upload it one by one only. AC, DC, BLDC, PMSM, SRM. Yes, correct. SRM motor. And one more motor you have mentioned, you have forget to mention. SRM, induction motor, brushless DC motor, interior permanent magnet synchronous motor. Interior permanent magnet synchronous motor, you have missed it. Yes, okay, thanks. Thank you for your comment. And what are the right choice for the two-wheeler and then three-wheeler applications? What type of motor is the right choice for two-wheeler as well as the three-wheelers? Yes, Mr. Kasirajan, correct. Interior permanent mounted permanent magnet synchronous motor. Yes, BLDC and I mean BLDC and then DC motor is the two for the two-wheeler as well as the three-wheeler applications. Whereas for the high power applications, we have to go for the induction motor or PMSM motor or SRM motor, right? Hub motor, gear motor, it's again it's one of the type of the motor, but major classification depends based on the working principle only. You should understand. So suppose if you are facing the question what are the types of motor in the EV systems, you should not tell the hub motor initially. So always you should tell the major classifications of the motor like a BLDC motor or PMSM motor or interior permanent magnet synchronous motor or switch reluctance motor. Synchronous reluctance motor. So any one of the things only you have to mention. Yes, thank you. So thanks for your comment. And after that the motor we have to choose the right controller for the motor. Suppose if it is a DC motor, we have to keep one full bridge 4-coordinate chopper. If it is a AC motor, we have to keep one inverter module. For the inverter module, the same topology for a BLDC and induction motor and then PMSM motor. Whereas if you are going to use the synchronous switch reluctance motor, then you have to build your own asymmetric converter, symmetrical converter or asymmetrical converter. Any one of the converter we have to develop as per the motor configurations. And control signal. So the control signal is nothing but the drive signal. See, because actually always the vehicle is not a constant speed applications. Right. So what are all the type of applications like a constant speed applications as well as that variable speed applications? Our EV system is comes under that variable speed applications because we have to drive the vehicle on very safe manner. We cannot consistently we cannot run our vehicle at a constant speed. So wherever the brake needs to be applied, then we have to apply a brake. Right. So in that case, the control signal is going to control the entire blocks. So for this one, the major power we are going to extract from the battery. So what are the types of battery? So what are the types of battery? As I mean, there are a lot of types are there, but whatever we have discussed in the classes. So can you please comment? What are the types of battery? Can you please comment? Yes. So generally lithium ion, lithium polymer, and nickel hydrogen nickel cadmium. Yes. So like that. Great, thank you. So let's recap our basic vehicles. See, actually, as we know, if you want to develop the EV system, first we should know the basic calculations, how to calculate the motor power. So to calculate the motor power, you should know what is the friction force and then what is the push force. So push force is generated by the motor to drive the vehicle from standstill position. By default, due to the gravitational force and other friction force available on the vehicle, so since it's a mechanical systems, so we should understand the basic concepts, right? So we have to overcome the friction force to drive the vehicle from standstill position. So in that case, there are different type of friction forces will be available. How to calculate the motor power? The total tractive force. So the tractive force nothing but the overcome force between push force to gravitational force, that is friction force, and multiplied by the velocity of the vehicle. So that is called the total power or total power required to drive the vehicle. So in that case, we should calculate what are all the total tractive force which is available on the vehicle. Yes. So in that case, there are a different type of forces are available and on the vehicle. So the first one is the rolling resistance force, aerodynamic drag force, hill climbing force, and acceleration force. In that acceleration, linear as well as the angular accelerations. Right. So here we have to calculate the rolling resistance and aerodynamic drag. So we have to calculate all these forces and then multiply it by the velocity of the vehicle. Then we can come to know about the total how much power is required to overcome these forces. Right? Is it clear? So now let us just recap quickly. We can recap the equations. So this is the rolling resistance force. So the rolling resistance force is nothing but it's a opposite. This force is going to act on the opposite of the motion, opposite side of the motion of your vehicle, and so we have to choose the coefficients based on the tire material, road material, and then tire dynamics, pressure, temperature on the tires. So everything we have to consider while you choose the coefficients, and other parameters like mass and then gravitational acceleration constant. So it's going to be based on your vehicle dimensions. Right. Similarly, the aerodynamic drag force. So this force is generally act due to the wind velocity. Right. So again, this depends your vehicle design. See, if you are going to allow your vehicle to pass the air in the air, so the air should not create your design should not create a huge pressure on in the front side of the vehicle. Right. So in that case also you have to choose the proper design. So in that case you have to choose the proper coefficients. Generally for the different type of designs you have to choose the values. Right. And similarly the hill climbing force. So generally the hill climbing force nothing but the angle between the run side as well as the length. Right. So how much is the length of the bridge or any distance. So generally we have to keep the maximum value will be like a 45 degree we can keep it. But whereas here the 20% is the safest design to drive your to calculate your vehicles. So while you choose the forces, so you have to keep in your mind always you have to choose the worst case. Suppose if you are going to climb your vehicle, my vehicle can run at 40 km per hour. In the sense, you have to calculate the motor for the 80 km per hour. Right, but in the actual specification you have to climb only the 40 km per hour. So that is called the safety standards. So because if you want to get approval from the government, then you have to keep all these things in your mind. Right. So now if you apply this value, then you have to calculate the total motor power to overcome these forces to run at a desired specifications. See, for example, if you take the basic dimensions of this one, then the motor power requirement is about 2.5 kilowatt is the motor power requirement. Suppose if you consider about rolling resistance and then aerodynamic drag force, right? So other things and all comes under this one. Right? Is it clear? So this is just a recap of the previous classes. So from the day 1 classes. Yes, dear participants, don't spam the chat. So otherwise we have to ban your ID from the chat. Yes. So now let us move to the open model with open loop and then motor vehicles. See here, this is basic controls. We are going to use it. Yes. Thank you, participants. So now we are going to see the basic demonstrations. Yes. See here, first let us understand the motor with the power electronic controller. Okay, so this is the DC motor. So can you able to see this diagram? So can you please comment? Can you able to see this diagram? So anyone, it is enough. Can you able to see this diagram? So please comment. Yes. Not clear. So now is it okay? So already we have seen this experiments many times. So now we are going to just recap this experiment. Yes. Yes. So here this is the DC motor, and after that this is simple gear. So now we are going to verify whether the motor is the motor is giving you the proper on state as well as that off state. That is called starting as well as the braking. So with the help of power electronic circuit. So this is the very first model. So here the motor is connected. This motor is connected with a simple gearbox. So the gearbox is going to divide the speed, DC motor speed by 2. Right. So here this is the motor speed measurement system. Speed measurement system. Right. So here we are going to measure the input speed as well as that output speed. Okay, so now we are going to apply a controlled voltage. So this is called here the 4-bridge MOSFETs is going to be here. For the 4-bridge MOSFET, we are going to generate a PWM control signal. So that PWM control signal is developed by this control model. Right. So here the frequency, then output voltage is going to be like a 400 voltage maximum, and this is the MOSFET, 4-bridge MOSFET. So it's just open the block. See here, this is the H-bridge motor drive system for the DC motor. Suppose if you are going to use the BLDC motor, we have to choose different motor, BLDC drive, or else we have to develop a 3-phase inverter system. So that is 120-degree mode of inverter we have to develop here. Right, and so here we are going to give you the acceleration. So the acceleration is nothing but, so at initially it will be a 20 Newton meter, right, and after that 45 Newton meter, that is a kilometer per hour. The 45 kilometer per hour is the reference speed, and at the same time at the 5th instant we are going to drive the system. So 10 seconds we are going to activate this one. Right. Similarly, here we are going to apply a brake. At 9th seconds, we are going to apply a 20 Newton meter is the brake value. Right. So the brake system is applied here. So these are all the controlled voltage source, which means that if you take a potentiometer, if you change the potentiometer, the knob of the potentiometer, so like that we are going to assign this as a potentiometer. Right. So the output, see here, this is the value. So initially the motor is started from 0, and at the 9th instant, so the motor is trying to reach to 0 value. Right. So the input speed is about 600 radian per second. Actually, I have not done any unit changes. So by default, it will give you, and due to the gear mechanisms. The input speed is divided by 2 is the output speed. So like that we can incorporate the gear mechanisms. So we have to include all these gear mechanisms. Suppose if you need 4 different speed system, then you have to include the 4 different logic levels to add those things. Right. So this is very basic DC motor. So now let us come to the second experiment. Yes. See here the same logic. So already we have seen this one. So the vehicle has connected in the LMS in the internship portal. You can get a complete step-by-step project development lectures will be available on the internship portal. If you are interested, you can go ahead. And because actually here very 45 minutes is very limited time, so we cannot finish all these 4 experiments. Right, so this is the vehicle body and then 2 tires. As per the data sheets, we are yeah. So as per the sample data, we have developed this one. Yes. Right, so this is the vehicle model, and then this is the brake system. So here we have manual brake is going to be applied, and second thing, this is the gear system, right? And after that, so here this is another control model, that is a power electronic controller. See here we have all the things we have used only for the like a controlled voltage source, like a simple 4 potentiometer logic we have used. See here these 2 values from the duty cycle controller. So we are going to multiply with this voltage measurement as well as the current measurement. So sorry, not a measurement, current source. Right. So like that we have modeled. This is a simple logic to generate this one, and this is the battery model. So like here the 24 cells is connected as a 4. From the equivalent circuit, 4.2 voltage is the per cell voltage. So like that, if you connect 24 cells in series, then you will get 100 voltage DC voltage, right? So this, if you apply this DC voltage, now we are going to run this vehicle with 3 different speed system and then braking mechanisms. Right, so this all comes under that open loop, not a closed loop systems. So if you run this simulation, if you power up your vehicle, then due to the gear mechanisms, the 3 different speed is going to be applied, and after that, due to the braking mechanism, the 2 level of braking has been applied. So these are all the just system verifications, not a final project. So this is just a system verifications. So from this point, we have to integrate all these things with the drive signal, right? So with the drive signal. Right, so here this is the second experiment, and the third one, yeah. See here, if you apply the open loop, so here from this one we can calculate the how much SOC is consumed, and then what is the balance SOC. Suppose if you run the same vehicle for 100 seconds, then about 2% has been used to cover this distances. That is called 1023 meter is the distance value. It's going to be covered. Alright, so here the same motor is covered for the 1000 meters. So the distance in the meter. Suppose if this vehicle needs to travel for 1000 meters, then 2% energy is going to be utilized. So balance 98% will be the balance percentage. So like that you can estimate the battery charges, right? So how to charge the how to calculate the battery balance charge? So by implementing SOC estimation method. So what is the SOC estimation method? What is the SOC estimation method? What is the SOC estimation method? So the Coulomb count is the SOC estimation method. Alright, so we are going to use the Coulomb count. So see here, this is the basic Coulomb count. Whatever this there, we are going to calculate the 100 Ah battery for the 1 hour. So that is the maximum capacity, right? So after that, this is the integrator model. So if you can measure with this ideal SOC T of -1, compare with this one, then you can get a balanced charge. So those who are all needs to be used for these projects. So please watch the please enroll into the internship to get all these projects. right? So this is the basic open loop vehicle model systems. So now we have to integrate all these things with the drive signal. So the drive signal is actually by default in the MATLAB. So there is a drive signals. So just search the library. Yeah. So drive cycle source. So this is the drive cycle source. As per the standards, there are different standards are there. So FTP 75 and then wide open throttle, and or else you can feed your own data. So like that. So if you take the basic throttle, then you can use this one to apply the value. Right. So now we are going to integrate all these things, because actually to develop this project I took I mean for each and every project I took more than a week of time to conclude all the projects, and I shown you the demo, but on the live demo it will take long time to integrate all these mods. So that's why I'm giving you the demo. Otherwise we can move with stage by stage. So now, so let us take another example. Another example. This is two. Yes. See here, we take the speed kilometer per hour, right? So this is the actual speed we are going to measure, and so this is the drive cycle source. So this drive cycle source is compared with the actual vehicle speed. So from this we can apply a PID controller. Okay. So this PID controller will generate a error signal. So from this one we can generate a duty cycle for the power electronic circuit. Right. So if you drive this one, see here, this is the blue color is the input line, and sorry, red color is the input line, and the blue color is the output line. So blue color is the output line. So wherever you want to apply acceleration, so during that acceleration the motor will run. So whenever you apply or if you release the acceleration, then the vehicle will should reach to the zero speed. So here, so this is the vehicle distance covered. See here, so here keep on distance is increasing. So once if the vehicle is not applied the acceleration force, so in that case the distance is still zero, right? So the distance is not increased. So like a 3,300 or something like that, it will be keep on here. Suppose if you take this one, okay, the two signal has been multiplexed. See here, there are the two different signals. Yeah, see here the red color is the reference signal. So that is the input signal, actual input signal, which is driving from the drive signal source. The blue color line is the actual vehicle performance. So now you can implement different controllers. See here you can work lot. At the same time here you can work lot. At the same time you can implement a battery different mechanisms, and then thermal management system, and then motor thermal management system. So here and all you can do lot of research, right? Any programming for running the simulation for vehicle method? No need. So just to simply click the run button, then you can run the vehicle. Yes. So this is the closed loop system. So other than there is no any complex. So it's a very simple logics to yes. So it's a very simple logic to implement the EV systems. Right? Is it clear? So can you please comment? If you have any questions, you please ask me. Which MATLAB version I used? Actually, I used 2019. Thank you, Manav. If you have any questions, you please comment. Ramadurai, what is your question? Any other controller than PID. So you can implement instead of PID, you can use a fuzzy logic controller. You can use a neural network controller. 2015 is not enough. So please upgrade your thing. So what is your questions, Mr. Ayadurai? Voltage rating 4.2 voltage is the basic voltage. Yeah, fuzzy logic controller is available in 2019. So 4.2 voltage is the each battery cell. So this is simply it's a basic equivalent circuit. So 4.2 voltage. Is any sample model of electric vehicle available on MATLAB? Yeah, it is available, but it's combined with the hybrid like IC engine examples are there. In PS lookup, applying for EV method run need any program? No need actually for the PS. For the lookup table, that is the terrain experiment, you have to just drag the data sets into the work area. So that is enough. Sanjay, can we create driving simulator? Yeah, of course you can develop your own thing. See, actually from here, so there is an option. See here, you can use your own Excel sheet to feed the driving input. So based on the suppose if you are going to run a vehicle for 1 hour, so in that case 3600 seconds you have to run develop the data sets. So in the data sets, how at the first second, third second, fourth second, like that you can develop the drive cycles. Yes, sir, Dr. Silfa, sir, we have an inner current control loop, outer speed control loop. Can you explain that in this circuit? Actually, here we implemented only the just speed measurement. Okay, so current control mechanism and all we have not taken care in this experiment. So in that case, first you have to regulate the speed, and from this speed, suppose if you are going to use this one, this is the current reference. So from this again you have to taken care the current DC motor current. So from this again we have to compare this reference and with the PI controller, and after that only you can generate a PI duty cycle. Yes. Karthik, why EV drain battery even stand still? Because there is actually self discharge mechanism due to the chemical property as well as the temperature. So that's why the EV battery get drained even though if it is in the standstill. List of library as to install to complete the course. You have to install the PS Simscape library completely. Simscape driveline, Simscape electrical, Simscape utility, and the Simscape mechatronics. So everything you have to install it. And after that drive scenario, that is called autonomous vehicle systems. And other than this, not enough. So these two things are major. But while you install the MATLAB, so better keep all the libraries. don't restrict any library. So better select all the libraries. That is the simplest solutions. Madhavi, can we get the model file? Yeah, you can download this model file from this internship portal. Sir, is it possible to get a real sample data before going to EV original model? See, actually the real sample data, which data? The drive signal is actually, again, it's a driver input signal. You can develop, you can create your own data sets. So for that one, there is no any much complex. So yes, Dr. Silfa, that the current control I have not concluded. Taken care into this experiment. Pranav, please unlock previous lectures at least 2 to 3 days. Sorry, actually this is our system. If you want to use this one, so better keep enroll in the internship, so you can get all the content from the 60 days access period. Lokesh, I think you are asking the same question from day one onwards. Which is best? I think you are coming from mechanical background, I think so. Actually, hybrid electric vehicle, if you compare with the EV always best. Is any sample practice? See here, just go to MATLAB. So just to type demo. So you will get one window. So from here, you just search electric vehicle. Electric vehicle. Just search electric vehicle. You can get lot of experiments. Yeah. See here, electric vehicle configured hybrid and electric vehicle reference application designs. So all these things. So just to see here, there is a complete system. So just to click open this model. Just to open this model. So you can understand all these things. But see here, there will be a complete project file, so we cannot we may feel to understand all these things, right? So what is the purpose and everything, because actually they have developed their own standards, but we cannot decode sometime. We cannot decode it sometime actually. So like that, you can take any one of the examples. Yes. So please explain little about internship. See, actually here in the internship, you can get all the 30-day classes and the step-by-step video explanation along with the project files. Right? See here the MATLAB, all the MATLAB project files with the presentations, you can download it from the LMS portal. And from the day 60, you can get access for 60 days. Whereas in the YouTube classes will be removed in 3 days. After 3 days, this class will be removed. Right? Whereas in the internship portal, you can access all the 30-day classes for 60 days period of time, and you can get a WhatsApp support. And see here, suppose if you take this example, here in the internship portal, I will I have added step-by-step project building video lectures will be there. So you can follow the step-by-step video and then you can practice it. And if you are facing any issue while you are developing the project, in that case you will get a support from me. I will give you the answers if you are facing any issues for the technical issues, right? So based on this, if you follow the 30 experiments, then you will become a master in this particular concepts. So that is the whole idea. See, first you have to learn the concept, and then you have to practice the concept, and then you must become in the master, right? So this is the internship thing. Okay. Can we simulate complete diesel engine? Yeah, it is possible. The MATLAB has the complete IC engine setups. EV has speed limit. How it can be eliminated? See, actually the speed limit depends the motor type and then vehicle dynamics. See, actually nowadays there are a lot of technologies are there. If you visit this page, there is a one more motor. See, actually all of motors which we are using in the market. So these are all the axial motors. Just visit this page, so you can get more idea about the latest motor technology. So axial motors, axial flex motors. See here. So this is the axial flex motors. See, one more motors is there, that is called radial flex motors. So just visit this link. I will share you the link in this comment box, so you can understand more on this. So just visit this one. Yeah, see here. So there is in this video you can understand. See, see here, the traditional motors are the radial flex motors. So the latest motors are called the axial flex motors. So there is no any round shape. So instead of that, so we are going to get a complete new technology that is called yokeless axial flex motor. So this flex motor will give you wide speed range with wide torque range. So this is the new technology which is used in the motors, electric vehicles. So this method is 100% optimum solution for the PMSM motor and SRM motors, switch reluctance motors. So just watch this YouTube link to get more idea about it. Actually. Do you think biofuels will replace the electric vehicles in future? There is a chance biofuel, but still the market, the government, what they are going to decide, right? So that is the biggest challenge. But anyhow, the transportation industry is the biggest market for the entire world's government. So they won't allow you to take away easily. So because actually for each and every person have to spend for their travel expenses. So they are looking in that aspect only. If you want to travel by any vehicle, then we have to pay to them. So this is again huge lobby is going on. So whether still there is a huge debatable point is there still whether the EV is required or not. Because if you compare with the conventional fuel, still there is a there is a issues in the environmental for the conventional fuel. But in the EV technology, again in the battery recycling is the again biggest challenge for the manufacturer. So after 5 years in the EV batteries, so there is no any solutions. So simply it's going to be a scrap. So in that scrap we cannot again reuse it, right? So we cannot handle that chemicals, we cannot handle that electrodes. So simply it's going to be a scrap. So in that case, after over the period of time, so again the scrap will huge. So if you have a better solutions to replace the battery recycling, then you will occupy the market. Yeah, Shubdeep, there is some reference IEEE papers are there, so you can use, you can check with that one. right? Similarly, one more example I should show you. Yeah. See here, this is again very simplest method. So drive signal, as well as that you can change the control signal, and if you applied this one, then you can easily vary the value. See here, the same logic whatever we used. So instead of complete PI controller, so here in the MATLAB there is a longitudinal drive signal. So this drive signal, if you apply the drive signal, so this drive signal will generate a acceleration command as well as the deceleration command. That is called the braking mechanisms. So under this one, we can use the same logic whatever we use the DC motor control. Right, so the same control we can implement here, and after that we can implement the battery model. So here the battery model system, and this is the vehicle body, simple vehicle body, and we can take output. So now if you run this one, so the yellow color is the reference one, and then blue color is the actual one. So by tuning the PI controller, then we can get a we can change the electric vehicle resolutions. See here, so the brake has been applied and then it approaches to 0, but here the speed is slowly it's getting reached 0. So here it's of course, so here we can implement a more control logic to reach the motor at 0 speed, and whenever it reaches the maximum, then we can maximum speed. So like that we can implement the control signals, right? So like that we can develop the logics. So now you can ask your questions. Thank you, Gangaram. Thank you for your Bharat. Of course, you should have a power electronic knowledge to become a EV systems. Yeah, Mr. Yash Kumar, CNG vehicle also it's highly efficient than the other vehicles, but still there is no any. If you compare with the EV, then the CNG will be a less priority. If you compare with the EV, then CNG still there is a issue. Lina, can you provide separate webinar for power electronic in EV? So actually the power electronic webinar we are going to start shortly. How to use how to join batch 4 EVs? Just visit this one, Pantech e-learning. Just visit this page, Pantech e-learning. So go to electric vehicle design masterclass. So just select this one, electric vehicle design masterclass, and see here. So there will be option. Just select add to cart. So just select add to cart and use this one. If you are existing customer, use this one, and if you are a new customer, you please click this one. So just apply this one, coupon code batch 4. So BATCH batch 4 EV. So just apply this coupon code, so you will get a discount. So you will get a discount, and then fill your informations and then proceed with the payment. So here you can use any one, debit card or credit card, net banking or wallet or UPI, any one you can use it. Thank you so much. Thanks for your valuable time. So I will share you the link in the comment box. I will share you the I will share you this link in the comment box. So please use it. This is batch 4. Coupon code is batch 4. Batch 4 EV. For high power motors like electric buses or trucks, synchronous motor, permanent magnet synchronous motor, switched reluctance motor, synchronous reluctance motor. So these are all the motors which is used. Thank you, Shadushain. Thank you, Bharat. Thanks for your comment. If you have any more questions, you please ask me. Thank you, Shadushain. If you have any more questions, you please ask me, and please share your video feedback to my WhatsApp number. Thank you, Hariharan. Thank you very much. Thank you, Mudab. Thank you, Govindraj. Thank you, sir. Hybrid vehicle, I didn't touch that vehicle because actually I am from electrical background, so I know I don't have much idea about the IC engines. That is a basic idea. I don't have much idea in the IC engines. Ravi T, how to use real-time data in data sheet? See, actually, there is an option to include your real-time data sets. Like you have to convert the real-time data sets in Excel sheet. That Excel sheet you can incorporate to the MATLAB. So that option is available. Battery recycling is possible. Yeah, of course, but it's a very considerable amount, not a large scale. So while if you are doing the battery recycling, there is also actually a huge environmental pollutions are there. Three-phase AC motor for electric buses, yeah, sometime, but latest vehicles comes up with the PMSM and then SRM motors. Yeah, if you have any more questions, you please ask me. Lina, actually, we are going to start offline internship also. So in the EV, particular EV, we are going to launch soonly. I will share you the video of the real-time electric vehicle, so which is used in our laboratory. So I will share you. I will share the information shortly. Shadushain, I have noted your point, but actually in this class itself, we have included 4 different classes. So this information is more than enough to kickstart your research. Yes, if you have any more questions, you please ask me. Thank you, Indumati. So you please share your video feedback to my WhatsApp number. Yes. Thank you. Thank you for your valuable time here. So we will see